Now let's try to do this question number 4 from summer 2009 calculus 3 test 2. Now we need to write of these two surfaces. The first surface, x squared plus y squared equals to 5. I hope you realize that this is actually a cylinder, and which is parallel to the z-axis, and this is a plane, which is also a cylinder because it's missing the y-axis. Now the first question we have is to find the intersection of those surfaces in parametric equation. The one we will use first of all is the one parallel to z-axis. Notice that we learned in class how to parameterize this. This S1 here is a cylinder with the shape of, if we project that on the xy plane, it will be a circle, which gives us the hint that we will parameterize that in the following direction. The radius is radical 5, so I will use radical 5 cosine t and radical 5 sine t. Now together with the second surface, x plus z equals to 4, that implies the z equals to 4 minus x, which from the parameterization we have of that first surface, I will call that 4 minus square root of 5 cosine t. In other words, the intersection of these two surfaces in parametric equation will be a path that is given by this. And the c will be 4 minus square root of 5 cosine t. Now, in general, we can't really do, in general, if you have two surfaces, we can't really do this kind of things. At least that's not something quite easy. However, this question becomes quite easy because the projection of this surface, the cylinder, onto the xy plane will give us a nice circle with radius radical 5, which then we parameterize this way. Now then the idea is, for the second surface, we see the relationship between x, y, and z. Solve for z. That's the thing we will put into the z component here. Now, in the second part of this question, we want to find the equation of the line tangent to both surfaces at that point. Now, notice that the intersection of those two surfaces now being parameterized by this, by this path here. Let's call that RT. Is given by radical 5 cosine t, radical 5 sine t, and 4 minus radical 5 cosine t. Now, therefore, if I want to find the equation of the line tangent to both surfaces, it must be also the same line that is tangent to this path at that point. Is that right? Now then, to do so, I will do the first derivative at t here. That will be negative radical 5 sine t, radical 5 cosine t, and this will be radical 5 sine t. Okay, now honestly we don't know what is the t at that point, but if we think about this, notice that this at this t here you reach 1, negative 2, 3. That's the position factor, which means radical 5 cosine t is 1 and radical 5 sine t is negative 2. Okay, now using that situation, we'll find that at that t there, let me call it t1. At that t there, the value of the r prime will therefore be 2 for this, because radical 5 sine t is -2. This is the opposite of that. And this one will be 1. What will this be? -2. Therefore, the equation of the line tangent to both surfaces at that point will be given by will be x minus 1 over 2 equals to y plus 2 over 1 equals to z minus 3 over -2. That's for